those who have got your textbook, please look at your questions. Okay. Now, what is population, what is sample, and what is the difference between them? Okay. So we go to the first concept that we discussed earlier. What is sample? What is population? Population as simple as the entire collection of objects or individuals or the things. According to your video, they refer that as a things, anything that is inside your interest of study. So entire or all of your subject, object, things included in your data. So that would be population. What about sample? Okay, this is for me just to answer. There will be question that I want you to answer. Okay, what about sample? Sample is if we are talking about subset of the what we call object or subject or things that we study from our population. That would be the definition of population and sample, simple way. And what is the difference between them? What do you think the difference? Class, what is the difference between population and sample? Obviously, first, the obvious difference would be what? Hello?
Population is large in number.
Huh? What was that just now? What will be the difference? Huh?
Population usually large in number.
Your N will be greater than your sample size. What next? What else? If you're talking about the size, the number of sample will be smaller than your population. Okay, so what will be the other difference that you do is the coverage of your sample, which covers subset of your population, whereas the population will cover everyone in your data set. Now, next, true or false, a sample is a subset of people or object in a population. Definitely it is true, right? Okay. What is parameter? What is statistic? What is the difference between them? What is parameter? What is parameter? You can, you can flip over your textbook and give me the answer. So it will be easier for me. Just quickly discuss the question. What is parameter? What is parameter? If we're talking about population.
Numerical summary of population.
Yes, parameter is numerical summary of your population. For example, if you are talking about, this is question number 3. Okay, if you are talking about population mean, okay, you are talking about mu. If you are talking about population size, you are talking about n. If you are talking about population variance, you are talking about sigma squared. What about statistic? What about statistic?
Sample.
What about sample? What is about sample that we call statistic? It's the numerical summary of your sample. For example, if you are talking about sample mean, we are talking about X bar. If you are talking about sample size, we are talking about N. If you are talking about sample variance, we are talking about S squared. So these are all about parameter and statistic. The representation of your numerical summary will show whether it is parameter or statistic. Next question. Okay, what is the difference between them? So you can see clearly the difference between them. Okay, the notation wise and everything. Okay, true or false, a parameter describes the characteristic of a population of interest. Definitely true, right? because we are talking about the population of interest. Explain the difference between descriptive and inferential statistics. What about descriptive and inferential? Number 5. Descriptive and inferential. Plus, what about descriptive and inferential? What is the difference? This should be a discussion class, yeah? Okay, the difference between descriptive statistic and inferential statistic, what are they? Class? What is descriptive statistic for? To describe data, right? To describe data. To describe data in terms of what? In terms of graphical and in terms of numerical. So numerical can be measure of central tendency, measure of dispersion, and measure of location or position. Okay, must measure of position. What about inferential statistics? Class that differs from descriptive. So it means that for your project 1, your analysis is just about how you can describe your data, and you can, by using your descriptive analysis, you can make some analysis, simple analysis from your data. So that would be descriptive statistics. But beyond that, which is much more, I think, complicated, it will be inferential statistics. What is inferential statistics? Right? What about inferential statistics?
Making inference about the population using selected sample.
Making inference of what? For example, making inference of your mu, could be for proportion, for example, for the population using the sample. Okay, so it's different context of discussion. So descriptive statistic is just about how you can use your graphical form and numerical form in terms of representing your data, so that you can reveal the meaningful information that is remain in your data set. But inferential statistic is where you are going to use the data set and you do some analysis, okay, some selected method, and do the analysis for you to make conclusion for your population using the sample. So that would be the difference between descriptive and inferential. Now, question number 6, true or false? Already write down the answer over there. The purpose of inferential statistics is to simplify and organize the data from a research study. Definitely wrong, false. So it's not about simplifying. It's about making inference, making conclusion, okay, for the population. Give an example of a variable. Why it is called as variable? Can you give me one example? What is variable? Give an example of a variable. Number 7. Simple example.
Length.
Length, yes. Other than length?
Height is.
Weight. What was that just now? Length, weight.
Age.
Age, yes.
Gender.
Gender. Okay, let's say we stop there. Now, what was the question? Next question. The next question is, why is it called variable? Why do we call this as variable? Why? Because this is, or in this case, these are the interests of our study. Simple way. Or if you want to call it in a more appropriate definition, it will be the characteristic of interest of your study. So what are the characteristics? Including length, weight, age, and gender. And if you are looking at your variable here, this is what we call quantitative. Okay, so this also quantitative. What about this one? This is what we call qualitative or what we call categorical. Okay, do your categorical or qualitative variable include shows any ordinal or nominal? Is it nominal or ordinal? Last, this kind of age and gender, is it ordinal or nominal?
Nominal.
Nominal, because they are not in order. So they are nominal. Okay. Now, next question, number 8. Give example of qualitative and quantitative variable. What is the difference between the two? Yeah, we have discussed this. Okay, so this come along with question number 8. Okay, now question number 9. Question 9. Briefly explain the difference between observational and experimental study. Why the difference is important. Okay, number 9, you are talking about your waiting for my okay. Number 9, you have observation versus experiment. Okay, what is about experiment and observation that differs? Okay, here you observe. Here you also observe. But here you observe with an attempt. Okay, with an attempt of what we call in attempt for your research, attempt of research. Here you just observe. Okay, so if you look on page your what we call explanation between the observational and what we call experimental, so you can see clearly the difference between the data that you will have from your observation and that you get from your experiment. So in terms of data here, everything based on your observation. Here, your data is reflecting your attempt of your research interest. So if you're talking about the, last time I said about the fertilizer and everything, so different types of fertilizer will affect the data that you are going to collect at the end of your research study. Okay, so that would be on the observation versus experiment. Now, number 10. Sampling is a process where researchers select a portion of the total population to be included in their study as opposed to true or false. Sampling. Last, number 10. Sampling is a process where researchers select a portion of total population to be included in their study as opposed to studying the whole population of interest. True or false? Last, sampling. Sampling. We are not talking about sample. We are talking about sampling. The way we choose the sample. This is what we call sampling. The way we choose our sample. Okay, since it is a process where researchers select a portion, okay, to be included in their study. So this is true. Okay. Number 10. Now number 11. If every individual in a population has the same chance of being included in a sample, the sample is an, what we call that? What kind of sample is that? What was that, class? We choose whereby every single subject inside our population is having the same probability, the same chance. So this will be
Random.
random, yes. Okay. The simple random sample is a sample from the population in which every member of total population has an equal chances of being selected. So it is this a repetition of what we discussed above. So it is true. Okay. To study the amount of time students spend doing homework each day, a random number generator. What type of something? Just disregard this one. Not interested in discussing the sampling types. Okay. When one examines, okay, when one examines the entire population instead of a subgroup of population, this is called a what class? Entire population. When one examines the entire population instead of a subgroup. So I think this is referring to the measurement. Okay. What is this? What do we call this? I guess this is what we call a parameter. Okay. Now, the below part is the interesting part that I wish to discuss. Okay. Which of these measures, mean, mode, median, can be more than one value? Why? Now we are talking about question number 16. Okay. And I think I need to give some illustration for this one. Number 16, we are talking about mean, mode, median. We know that all these are referring to what we call measure of central tendency, where we have all these what we call all these value will concentrate in the middle, what we call in the middle value. Okay. If let's say I put the notation for mean is x bar, for mode is x hat, and for the median is x curly. Okay, let's say the mean here, okay, and this is the mode, and this is your average. Sorry. Okay, so we are talking about all the values will fall within the what we call middle value. Now, the question is, which of these measures can be more than one value? Can be more than one value. Which one, class? More than one value. Which one? Is it mean? Is it mode? Is it median? Guess. Can we have two means for one sample, for one data set? Can we have two more than one mean, class? Class?
No.
No. Yes, because what happened when we wish to calculate the mean, we are going to sum all the xi value where I will be from 1 until n, and this x summation will be divided by the number of samples. Definitely there will be one value. Okay, the same goes to the median. Median refers to the 50th value. Okay, 50th% or 50th value means that it will be in the middle of your data set. 50th value. So definitely there will be also one value. Okay, so median will be not more than 2. But because when we are talking about mode is the most frequent data with the most frequent value. So means that this could be, okay, for mode it would be more than 1, it could be equal to 1, or it could be nil, which is 0. No mode. So mode will be the only measure of central tendency that can have no value at all, no mode at all, can have one value of mode, can have 2 modes, can have 3 modes, or so on, depending on the data that you have in hand. So I hope by now everyone understands what would be the difference between mean, mode, and median, and which of these can have more than one value. Okay, question number 17. By using box plot, how to determine shape of a distribution and dispersion of a distribution. Now, I hope you have understood when you watch the videos with regard to the box plot. That will include the 5 number summaries. Okay, so 5 number summary is actually equivalent to the box plot. Now, what about the box plot and 5 number summaries that you should understand? Okay, 5 number summary means that you are talking about the mean, minimum value, maximum value, the median, and your first quartile and your second quartile. Sorry, third quartile. Your median is actually your second quartile. So 5 number summaries just tells you about the mean, minimum value, your first quartile, your second quartile, that is your median, your third quartile, and your maximum value of your data set. But when we are talking about box plot, okay, it's more than that. Okay, because we are talking about, we are still using the mean, we are still using the max value, we are still, let's say, we assume this is where the what we call the median is. Yeah, this is your median, this is your Q2, and let's say this is your Q1, and this is your Q3. Now, what box plot tells you is about the range of your data included in your every specific region. For example, the first region between the mean and the Q1 is 25% of your data set will fall within this range. And another 25% of your data will fall between this range, from here to here. The same goes to here, 25% and 25% here. So altogether, 100%. So box plot is whereby you are talking about the measure of position of your data. Okay, so this will indirectly discuss about the last part of your measure of central, the measure of position. So when we have this particular what we call division, we can talk about the middle 50%. Middle 50%. That will be between Q1 and Q3. And the median is your Q2. Okay? And you can also say about, we are talking about lower 50%, which is from here until here. And your median here, this is your median, is your Q1. This is your mean, this is your Q2. So this is lower 50% of your data. You can also say about your upper 50% of your data. Okay, upper 50% of your data, whereby it is from your Q2 until your maximum value, and your median is your Q3. So what you can understand is that you may have different median depending on the region of what you are talking about. If you are talking about the middle 50%, the median is your Q2. If you are talking about lower 50%, the median is your Q1. If you are talking about the upper 50%, your median is Q3. So here, the concept of median applies. So what is median? It's the mid value. It's the 50th value. It's the 50th% of your value in your data set. So what is the question just now? By using box plot, how to determine shape of a distribution and a dispersion of a distribution. Okay. If you can remember one of your what we call video discuss about how you can identify your distribution of data by using your box plot. Okay, this is how you can do that. Okay. Okay. Now, let's say we are talking about this kind of box plot. For example, this is example 1. Okay. Example 1, if let's say you have what we call, the first case would be, you have your middle 50% where your median is located here. Okay, so this is your Q1, Q2, Q3. And this is your, what we call your whiskers. Huh? Right. And from this, what we call box plot, your video says that if we are using your, what we call this particular region, what happens is that look at the boxes inside the Q1 until Q3. Is it equal or not equal? So in this case, your box plot have larger range here. So means that in this particular case, you will have what we call this particular what we call distribution. So in this case, by having this box larger than the other box, we can say this is skewed to left. Right. Example number 2. Now, what if you have equal sizes? You have equal sizes, whereby, okay, assume that this is equal, okay? This one and this one is the same, okay? So, and you have this particular whiskers also the same. So, this is where you will have what we call symmetric distribution. Okay, left skewed to left distribution. Okay, so it's either you can use your what we call this particular box. Okay, also using box. If let's say you may have this kind of what we call box plots. Example 3. Okay, whereby you may have, for example, you have very short middle 50%, and they are almost the same. Okay, almost the same, but one of the whiskers are very long. It's very long. Okay, so in this case, these whiskers, okay, show very what we call long whiskers. So in this case, you are using your long whiskers as your guide. And in this case, you know that this is your what we call to the right distribution. Skewed to right distribution, or sometimes we call it as right skewed distribution. The same. Okay? Clear or not, class? Class? You clear? Do you understand what I'm explaining to you, class? Hello?
Okay.
Clear, eh? Okay, now, so in summary, you can use your box, okay, as your guide, or you can use the whiskers as your guide. Hopefully, whenever you see any box plot, okay, you can use either one as your guide, or maybe simultaneously you use the box and the whiskers to guide you in identifying your data distribution. Now, question number 17 done. Explain, number 18, explain the relationship. 18, explain the relationship among measures of central tendency and a skewed distribution and symmetrical distribution of a data set. Okay. Now, number 18, we are talking about what we call symmetrical distribution is where we have, assuming that this is symmetric. When we say symmetric, okay, we know the mean is actually equal to the mode is actually equal to the median. Now, this is what we call symmetric distribution or normal distribution. Understand, class? When you have symmetric distribution, remember all the measure of central tendency share the same value. There will have one value and that one value is referring to your mean, to your median, to your mode. So that is what we call normal distribution or symmetric distribution. Now, what about skewed distribution? Okay, when you have skewed distribution, for example, you have left skewed and you have right skewed. Okay, what happens is that your each and every single value of your x bar, x hat, and x curly will be different. Okay, the median will always in the middle. Okay, and for left skewed data, you will begin with your what we call mean, and your what we call your largest value will be your mode. So this is your mode. So in this case, when we are talking about skewed data, and if it is left skewed, we can say that your mean, okay, mean is lower than your median, and your median is lower than the mode. Okay, in reverse to your left skewed, we have what we call right skewed. Okay, when we have right skewed, we will have here the median. Okay, let's say x bar, x curly, x bar, x hat. Okay, this is your x curly, and this is your x bar, and this is your, the mode should be a peak. So let's say this is the peak. So this is your mode. Okay, so what happened for right skewed? Okay, what happened? You will have your mode is lower than your median, and it is lower than your mean. Okay, so that would be your understanding that you should have when you are talking about the distribution of your data. If your distribution is left skewed, right skewed, or symmetric. Understand, class?
Yes.
This is okay. Thank you. Simple concept that you should remember. Okay. Last time when we have what we call test and exam and everything, this really mess up among students. Okay, because they don't really understand the whole concept of that. Now next question, number 19. Okay, number 19. What will be the question? Explain the difference between measure of central tendency and measure of dispersion. Okay. So what is the difference between measure of central tendency and measure of dispersion? Okay, that would be number 19. Okay, it's past 1 hour. Okay, so when we are talking about measure of central tendency, okay, we are talking about the center of data. So this is your measure of central tendency. So we are talking about the mean, the mode, and the median. Okay, we are talking about the x bar, x curly, and x mode. Okay, everything centered in the middle. Okay, but when we are talking about measure of dispersion MD, okay, we are talking about the how the data is distributed, okay, from minimum to maximum. So if that is what we call range. Or if you are taking into account the central value, that will be the x bar, okay, and you are going to calculate, as I mentioned earlier, each and every single distance from every single points that you have to your data mean. So you are talking about the variance and standard deviation. Okay, how much it deviates from the central value. Okay, so that would be measure of central tendency and measure of dispersion. Now, number 20. Is it possible to get a negative value of standard deviation? Plus, is it possible to get standard deviation negative? So what is your standard deviation? So let's say standard deviation is square root of your summation xi minus x bar squared divided for I equal to 1 until n divided by n minus 1. So is it possible to get negative value here? Is it possible? Plus?
No.
No. Because why? Why? Why plus? Because when we are talking about, we are squaring, okay? Square. We square all the values of the difference, right? This is the difference. And each and every difference will be squared. Means that if we are talking about distance here, this will be negative distance, right? But when we square them, it becomes positive, right? Here is already positive. Square them, also positive. Okay, that's why it is impossible to get negative value of standard deviation. Okay, how to calculate your interquartile range? Question number, so this question number 20, question number 21. Okay, how to calculate your interquartile range? What is interquartile range? Interquartile range, if we are subtracting your Q3 with your Q1, that would be your interquartile range. So if you can remember, where do we have that? So if you are talking about your box plot, okay, so you have your mean, you have your max, you have your Q1, you have your Q3, you have your Q1. Sorry, Q2 here. So your interquartile range is this one. We are talking about your middle 50%. Okay? Middle 50% of your data. Okay? That is what interquartile range tells you. Okay? Now, number 22. For a given box plot, how do you interpret the median, second quartile, first and third quartile? How you describe the median? Let me show you the question. Okay, so question number 21. Okay, sorry, question number 22. For a given box plot, how do you interpret the median of the second quartile, first and third quartile? So again, you are talking about your median of each lower, middle, and upper of your 50%. So 22 is max. Let's say Q2, Q1, and Q3. So this is the median. What? Median of what class? Median of, you can say for median for 50 of 50% of your data. Okay. And this Q1 is what? As I mentioned just now, is your median for 50, lower 50% of data. And your Q3 is the median of upper 50% of your data. Okay, understood class? So that would be question number 22. Okay, number 23. I really hope that you can relate every single discussion that I made with the video along with your understanding of the chapter material. Then, which measure of dispersion, range, standard deviation, and interquartile range would be the best for a skewed distribution and a symmetrical distribution, and why? Can someone guess? Let's say for what we call skewed distribution. For skewed distribution, what would be the measure of dispersion good to represent? Is it range, standard deviation, or interquartile range? Ask. Class? How many of you are inside the class now?
Still thinking.
Still thinking?
Interquartile range, I guess.
Okay, let us see. Let us see what does affected by the value. So question number 23. First, let's see, we are talking about symmetric data. Okay, symmetric data means that you have what we call your equal balance box, equal boxes, equal box. Okay, so this is your Q1, this is your Q3, this is your Q2. The question is now, which measure of dispersion? So you have range, you have your standard deviation, and then you have your interquartile range, IQR. That will be for symmetric. But for skewed, let's say we choose skewed data set. For example, we have this kind of data. And obviously, we can see this is skewed to the right skewed. So which one is the best? Range, standard deviation, IQR. Which one?
Interquartile range.
Which one? This one?
IQR.
A, B. Interquartile range for which one? A or B?
For B is interquartile range because it can tell whether it is out of order or what.
Okay, for A?
For A, not sure.
The rest? Anyone else? Let's guess first, and we'll do the analysis one by one.
Standard deviation.
Standard deviation. Okay, let's see. Let's analyze. Now, what is standard deviation? Standard deviation means that you, STD is summation of xi minus x bar squared divided by n minus 1. Okay, so standard deviation, square root. Now, when we talk about standard deviation, we are talking about the dispersion from the mid value. And the mid value for symmetric, this one is symmetric or normal. This one is skewed. Okay, for normal data, we know that every single middle value share the same value. Okay, and we know if we are talking about among the three, if you are talking about which measure of central tendency best for symmetric distribution, then your answer is X bar. Okay, best measure of MCT for symmetric data. Because why? Because we know the location in the middle, and when we calculate the mean, we take into account every single data in your data set without miss. So everything is calculated, so it is more precise compared to median and mode. So that's why for MCT, for symmetric distribution, we will choose X bar. When we are talking about the what we call the range and the dispersion of your data, if we are talking about your dispersion for symmetric data, obviously, I believe your standard deviation can be used to represent the what we call the distribution of your data. Okay, your IQR could be possible depending on the case of what you are looking for. If you are looking for the whole data set, so every data is included here. Every data counted here. But when we say about IQR, we are talking about middle 50% included. Okay, so I guess for this particular symmetric, standard deviation is the best. But when we are talking about skewed data, skewed distribution data, definitely standard deviation is no longer your choice, because we know standard deviation only for normal or symmetric distribution data. Is it range okay? Now, imagine if you are talking about the range, you are talking about the minimum value to the maximum value. If, let's say, there are points which is very large or very small, it will affect your range. So range will be no longer good to represent the distribution of your data. So if you have skewed, yes, IQR will be applicable for your distribution of your data. And it will not be affected by the data inside your data set. Okay, I hope everyone understood. Okay, now question number 24 is a repetition of what I have discussed just now here. So question number 24 is is the mean or median a better measure of central tendency for a data set with outliers? Now, in this case, I would like to give you an ordered data. For example, you have 2, 2, 3, 3, 5, 5, 5, 8, 8, 8, 15. So how many sample inside here, class? N is equal to what? 1, 1, 2, huh? How many? 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What did I miss? 3, 3, 5, 5, 8, 8, 8. Oh, there's another 8. Okay, I need 12. Now, what is the mean? As simple as if you are calculating your mean, x bar will be sum of this value, sum of all xi, where I is from 1 until 12, divided by the number of samples. So if you sum all of them, you will get 72, divided by 12, that is 6. Now, if you are using your mean will be where? Somewhere over here. Somewhere in the data set. Line your mean. Okay? The mean. X bar. Okay? Now, if you are using your median, okay, median is the 50th ataupun kita panggil 50th observation. Di tengah-tengah. Okay? If you are talking about 12 data set, means that it is between number 6 and number 7. Okay? So 1, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is your median. So in this case, for odd sample size, the median falls between the two values. Okay? But for even sample size, the median will fall exactly on one value. That is the difference between odd and even. So in this case, what is your median, class?
5.
5, yes. It's between 5. So it should be 5 plus 5 divided by 2, you get 5 as well. So 5 in this case is your median. Now, look at your data set. What appear in your data set that is causing the difference of the mean is 6 and the median is 5. Can someone guess what is inside your data set that cause the difference? The mean you get 6 and the median you get 5.
More.
Hmm?
More.
More? What was that more?
Because the 8 is appear too many times.
Not really. Not really. Okay. Good try, but that is not the answer. Look at the data. Look at the data carefully and what obviously appear in your data set.
Number 15.
Yeah, it's the 15, right? 15 seems to be very large in your data set. In fact, it is, further away from 8. Okay? So instead of having 2 until 8, there is suddenly one data set with 15 value. Because of this 15 value, the maximum value is very high. So it will affect your calculation of your mean. Because mean will be calculated based on the data set that you have in hand. So in this case, mean is affected by large value. Okay? So affected by large value. That is 15. What about median? If you have 100, 101, 150, whatever number of your sample size, the median will always be in the middle of your data set. So it will not be affected by the minimum, very low value or very extreme value. So median is what we call resistant to your outlier or extreme value. Okay. The question just now is, okay, resistant to outlier. Because it does not affect the what we call the position of the median value. Okay, so in this case you have what we call even. So sorry, this is even, even value. What if I have odd value? Okay, I have 2, 2, 3, 3, 5, 5, 5, 8, 8, 8, 8, 8. My n is 11. And this is odd. When it is odd, the 50th value falls exactly on a value. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is your needed value. So this is located 50th in your, my handwriting is so bad. 50th value of your data. So that is the difference between if you have odd value of sample size and even value of sample size. Now from this data set, before I forgot, let me save this. Okay. Okay. Now, what is the mode here, class? Can you tell me the mode here?
Egg.
The mode, what is the mode?
Egg.
1, 2, 3, 4, 5. 5, 8, 1, 2, 3. So 8 is the mode because highest frequency. Okay, highest frequency of your data. Okay, if let's say I have, for example, if I change a bit, I have 2, 2, 3, 3, 3, 5, 5, 5, 8, 8, 8. What is my mode here?
3, 5, 8. 3,
Yes,
5, 8.
3, 5, and 8. Obviously. Any shared values, any shared numbers of frequency, it shows that it will have more than one mode for your data. So that's all for your part 1. Okay. Do range affect by outlier? Question number 25. 25. Range and outlier. Do range affect by outlier? Do range affected by outlier? Is it range affected by outlier, class? We have just discussed this about this one just now. Is the same goes to the range. If you have outlier in your data set, either very small data or very large data, does it affect your range, class?
Yes.
Yes, doctor.
Yes. Yes. Range is affected by an outlier. Either very small data value or very large data value. So these are all the concepts that I wish you can understand whenever you look at your videos and when you read your textbook. Okay, because so far we will be based on the videos itself, so that will be among the discussion for part 1 of your tutorial 1. Now let us move to your part 2 of chapter 1. Okay, so your part 2 of chapter 1. So look at question using box plot number 11. Okay, let me snap the picture. Forgot to snap the picture. Okay. Let me snap the picture so that I can. So everyone look at question number 11. Read the question. I wish to cover question number 11, 13, but it seems that it will be in the next discussion. Okay. Let me stop sharing for a while. Let me paste the picture. Okay. I'm sorry, there will be no rest because we just have our limited time. I don't think I will have enough time to do the Excel because question number 13 will be using the Excel. Okay, so I'll just give you what we call homework for that, to do something with here. No, question number. Can someone check how many are they inside the online class now? Can someone check? Or no one is inside? Huh?
Total got
How many?
51.
51. Why so many are not attending?
51 participant.
Okay, thank you. Now look at question That's my tutor. Okay, now let me share question number 11. Okay, so this is question 11. Now, looking at the box plot, okay, you have the box plot. Now we are going to analyze. Last time, this kind of question is the what we call the haunted question for students, because this is where students need to think a lot, need to relate with the understanding of all the graphical and numerical representation of data. Okay, so in this case, you are given two two box plots for class A and class B, and you have score in your what we call x-axis here. Okay, you have the x-axis. Okay. Okay, now state the variable. Can someone tell me what is the variable in this example, in this question? What is the variable?
Class.
Class A and B.
Look carefully. This is how you this is exactly how you will interpret your secondary
Score.
data set. Yes. Okay, number one, the variable is score. Why score? Because it's mentioned here. Is the interest of study that is being discussed. We are talking about the score from class A and score from class B. Okay, and the score is from 60 until 69. Okay, and we have different distribution for class A and this different distribution for class B. Okay, before we go into detail to each of the question, let's study the box plot first. What can you tell about class A? Class A, what can you tell? Tell me, based on the discussion that we have made just now, what is about class A? Relate to your measure of central tendency, relate to your measure of dispersion, relate to your IQR, you can relate to your range. Class? Class A first. Class A. So for class A, what can you tell first about your data?
Left skew.
Yes, more or less left skewed. Okay. Other than that, what else?
The mean is less than the median.
Okay, hold on. My daughter is in that. I need to open the door. Okay. What was that just now? The median what?
Median, the mean is less than the median.
Okay, the mean x bar is less than the median. Okay, next. What else? Large range, right? Large range, large IQR, right? Compared to A, right? Compared to class A. Compared to class A. Class B. Okay? The same goes to class B. Okay, you will have what we call, do you have, what about the distribution of your class B? Is it skewed? Is it almost symmetric? Or what? Just guess. Based on the whiskers?
Almost symmetric.
Yes. For class B, almost symmetric or normal. Okay. What else? When we almost normal, almost symmetric or normal, most probably your x bar will be the same as x mode, will be the same as your x median. Almost the same. Okay. What else? Compared to in terms of the range and I to R, compared to A, small what? Small range and small I to R compared to class A. So these are all the compared to. Okay, so these are all the what we call how you can try to investigate from your data. What are the things that I can reveal from my data? What are the meaningful information that can be revealed from the data so that it will be beneficial for those who are going to see the result of your analysis. So this is how you relate to your project one. Okay, but looking at your data set for project one, we haven't do any analysis yet because your data set has been given in an organized form. So there will be ways on how to do the what we call the analysis. And I think I will be sharing that what we call Excel and for maybe using SPSS or Minitab on how we can do the analysis for that particular secondary data. Now for this question class, I don't think question number 13 will be possible for me to finish. Yeah? Okay, now we know the variable is the score. Okay, describe the distribution of both classes. Support your answer. Now, because you have already figured out above, so for class A, it will be left skewed. Left skewed. For class A, so class B, sorry, it will be almost symmetric. What else? Okay, support your answer. No, we haven't support our answer. Now, how do we support our answer? For left skewed, what can you support? How you can support your answer, class? One answer, please. What you can use to support your left skewed? Remember just now we are talking about the equal boxes, equal box and whiskers, length of whiskers. Now, what can you tell about the left skewed distribution?
Long whiskers on the left.
Yes, long what?
Whiskers on the left.
Yes, long whiskers to the left. Or you can see bigger box towards the left. If you can put it that way. Okay. What about symmetric? B, symmetric? You can also say about using the whiskers.
Almost same with whisker and box.
Almost equal whiskers length. Whiskers length for left and right. I hope it is understandable that way. Or we can say equal boxes that reflect the middle 50% of the data. Okay, so that's how you can support your answer. Okay, compare the median between class A and B. So how can you comment on the median of class A and B? And if you can see, if I'm not mistaken, this is the line for Q2 for class A, and this is for Q2 for class B. Okay, so B, and this is for A. Which one is bigger? Hmm? Obviously, which median is bigger? Median plus
A.
A is bigger than median plus B. Right. What can you say about the mean value for class A? What can you say the mean? What about the mean of class A? And we are talking about class A is this. And we know that it is left skewed. Someone says just now about the mean and the median. Okay, so that comment can be used here. So when you have skewed to the left, the mean should be greater or smaller than the median. Class, should the mean x bar and median, should it be greater or less than?
Less than.
Class, less than, because the mean will always be smaller than the median. So for question number 4, okay, mean of class A is less than median of class A. Okay. Now, what makes because why? What would be the reason we say this? Because what, class?
Because left skewed.
Yes, because the distribution of the data is skewed to the left. Done. Number 5. Do you have information about the mode? Now, can you guess about the mode? Do you have information on the mode? Do you have any information on the mode? Remember? So we are talking about class A and class B. What about the mode? Mode for class A, mode for class B. Remember, skewed, not skewed. If skewed, what will be the mode? Is it smaller, greater? Class A is left skewed. So the mode will be what? The mode will be greater or less than the median?
Would be greater.
Yes, the mode will be greater than the median. What about B? Almost symmetric. What about the mode and the median?
Almost equal.
Yes, almost. Mode is almost equal with the median. Good. Understand. Okay, number 6. Which class with smaller dispersion? What your answer? Now, when we are saying about dispersion, choose which one that you want to use for your dispersion. Are you going to choose the simplest one? That is the range. Or are you going to use the standard deviation, which is not provided in your data or in your diagram? Or are you going to use the interquartile range, because we are talking about the box plot? Okay, so which class with smaller dispersion? A or B? Smaller dispersion.
Class B.
B, definitely B, because you can see A and B. In fact, B is within this particular range of class A score. So means that So for that question, class B with smaller dispersion. Support your answer? How would you support your answer?
because it has a small interquartile range.
Yes, you can either use because it has smaller IQR than IQR class A. Right. Okay. So if you are talking about the range can also be used since it is not to say because yeah, when we are talking about skewed, maybe this particular data is too small, but you can also use your range to support your data in terms of talking about the dispersion. So you can also refer to the range. Range of class B is smaller than class A. Okay. Now, what can you say about IQR for class A and class B? Support your answer. Now, what can you say? So this question, last question, is kind of what we call repetition of this particular answer. Okay. What can you say about IQR for class A and class B? Means that you have to comment both. What about the IQR for class A and class B? IQR class A, IQR class B. What about IQR? What can you say? You can say larger IQR, smaller IQR. And then you need to support your answer. Support your answer. How can we support our answer? How can we support our answer? Support with your calculation lah. So IQR means that Q3 minus Q1, you get what? Q3 minus Q1, you get what? So if let's say you find the value from your what we call data here. Okay. So if you look at the value, you can guess what is your IQR, what is your Q1, and what is your Q3. What is your Q1 and what is your Q3 for A. So if let's say I assume the value is for this is 67 minus 64, you get 3. And this is 65.9 minus 64.6, you get 0.3. So obviously, 3 is larger than 0.3. So that would be your supporting answer towards the last question. What can you say about the IQR of class A and class B? I'll stop sharing. Okay. Okay, I'm really sorry because I'm not looking at my chat during my teaching. So thank you for all the answer in the chat room. Okay. So do you have any questions so far? Because actually my plan was to show you the let me share some of the content. Okay. I was planning to cover this part because this is question number 13. So it's supposed to be there will be ways on how we can come up with what we call table frequencies for numerical, for graph, for categorical, and whatsoever. And in fact, if you are using Excel, because why Excel? Because Excel is available in every computer, in every laptop, so you can easily access that. On top of Excel, you can also use Minitab, SPSS. That will be among the simplest software you can use for your project one. And if I have time to show you how we can use the Minitab or the SPSS, I will show you. But somehow, for the next class, I will show you how we can use Excel to find all the measurement of graphical, numerical, mean, mode, median, standard deviation, so on and so forth, using Excel. So that will be covered in the next class. So before we end the class, do you have any question, class?
Yes, doctor, I have one.
Yes, yes.
Regarding a previous question, the one is the class A and class B, right?
Mm-hmm.
We say that class B is almost symmetrical,
Yes.
but arguably if we can spot that it's slightly skewed to the right, is it still accepted as an answer?
Yes, but because in statistics, everything must come with your reason. If you can show that your reason is solid enough to support your answer, most of the time we will what we call accept your answer. But obviously for class B here, okay, for class B here, we can see it is almost symmetric because the whiskers wise almost the same. The box for lower 20% and upper 25% is almost the same for this particular what we call box between Q1, Q2, and Q3. Is it okay, my answer?
Yeah, thank you, doctor.
Okay, thank you. Any more questions? Any more questions? Okay, if that's so, I'll just stop sharing and that would be the end of our class. So thank you very much. Thank you very much, and I will assign you the question 13 as your task to what we call key in the data into your Excel. And in the next class, we are going to discuss on how we can do analysis using Excel for the statistics part. Okay, thank you very much and see you next time. Assalamualaikum and a very good afternoon.